All right, let's get this thing started. Today is May 29, 2019. It is about 1:20 in the afternoon. I'm super late compared to when I normally start, but we're going to get this thing done. It's been a crazy day. Been in meetings all day. Been having a lot of fun. Super, super, super excited to get started, though. Getting back on the decision tree stuff. Here's what's going to happen. Last week we verified, in fact, I did some stuff over the weekend because, well, I didn't do it over the weekend. I did it in bed last night. Let me pull this over. Let's go fast. Okay, we're going to pull this in. I'm going to reset this. Reset. There we go. So one interesting thing, I decided to look at this on my laptop, and on my laptop, whoa, it's faster. Like, insanely faster. Incredibly, incredibly faster. And I was like, why could that be? And then I was like, oh, well, I just got this laptop like a year ago. And, not even a year ago, really only like 5 months ago. And it turns out, processors get faster over time. Real fast here, before we get started, I'd like to thank a lot of people who followed me while I wasn't around. First off, Jordy, thank you so much for the follow. Manuter, thank you for the follow. Dat Random Tanker, thank you for the follow. Eamon Azam, thank you for the follow. Man, we're on 46. I never do this right. Zoltra Lord, thank you for the follow. And Todger Man, thank you for the follow. I really appreciate that from everybody. It really, really, keeps me motivated when people follow. It really, really makes it fun for me to keep coming out here and keep doing this. So thank you, everybody. I really, really, really appreciate it. Okay, taking a look at this, and I don't know how to zoom this. Help, zoom, GitHub, commands, start, repository, view. Okay, I have a work in progress. What we verified over the on Friday is that it is being almost entirely hung up on trying to load from memory in two separate places. Let's go take a quick look at those. The first one is right here. It gets hung up on trying to do this load. The second one is right here. This right here is also quite expensive. It is not doing this as a conditional move. I talked with a couple of people at work to try and figure out why it's not doing a conditional move, and the current idea is that moving bytes doesn't really work. They need to be converted over to something else, and casting them to something else takes more time than just doing the branch. So that's kind of frustrating. And it just is what it is, and we have to work with that for now. So instead, what we want to do is we're working on a way to get rid of these, right? Not to get rid of them, but really to optimize them. So we've decided that this code really isn't going to change that much. And instead, what we're doing is we're taking a look at the features. If we look at individual trees, which we should go ahead and do, because they're in data sets and we're looking at the trees. What we see is that first we start with feature 0, then we go all the way to 17, right? Assuming that we fit each of these feature branch things, each of these features into 4 bytes because they're floats, we can fit 16 of them into a page of memory. A page of memory has 64 bytes, so if you take 64 bytes, divide it by the 4 bytes we need for a float, you end up with 16, right? So every 16 of these, starting at 0 going to 15, starting at 16 going to 31, resides in a different page of memory. And what we're going to do is we're going to try to optimize it so that the number of pages that we have to load is minimized across all the trees, right? So any given tree is going to have, as well, we're not really going to do a full optimization problem. That'd be really, really difficult. Instead, we're just going to look at one pseudo optimization to see if there is like some value here. And that is, for each tree, minimize the number of pages that the features live in. And if this works, we should see about a 10% drop, which doesn't sound like a lot, and it's not really, but if it turns out that there's some value here, there is a lot further we can stretch this optimization. So we're just trying to get a general idea about whether or not it's going to be valuable or not. The way that we're going to go about this, and I started doing this over the weekend, is using this thing called a feature reorderer, right? So we have, come on, just stay open. So we have features 0, then we go to 17. Those are in different pages. 2 and 6 are in the same page as feature 0. 732, again, in its own page. 734 maybe in the same page as 731. It's not entirely clear to me. We'd have to do the math to figure that out. F8 and the same thing up above. 762 in its own page. F27 in another page, and you can see that this one tree has to touch like 5 or 6 pages of memory, like a lot of pages. And so what we're going to do first is we're going to count up the number of pages that each individual tree takes. We're going to look at the average number of pages that we have to load in order to get through all of the trees, and then we're going to try to reduce the total number of we're going to try and reduce the average number of pages per tree so that any given tree can evaluate much, much faster. That's the plan. So let's go take a look at how we're going to do that. First, let's just take a look at the lay of the land. This is in my, we're going to run the console app. In the console app, we're going to instantiate the model. This is the feature reordering step we're going to do. Then what we're going to do is we're going to expand all of the paths, right? We're going to take a look at this first to make sure that we are correctly expanding all of the paths for a single tree. And if that turns out to be true, then we're going to move on. The next step is going to be show me how many total paths there are. Hey, Alpha Geek, what's up? For the that is a good question. Why do I think that a memory page is 64 bytes? In every bit of experience that I've had with the processors that I'm working on, that is true. You can load 64 bytes into a page of memory. Let's go ahead and take a look at that, though. We should verify that. That's a great question. Not in here. It's going to be in... Close all of this. All right, here we go. What is my processor? How do I figure out what is my processor? OS memory pages are 4K or larger. So that's a memory page on disk. We're talking about memory pages in RAM. 4K, well, okay, so 4K, no, you mean in RAM. That's interesting. Okay, what is my processor? I want to say we can figure that out by going to Task Manager. Nope. Go to this one. Go to Properties. Nope. Come on. Properties. Okay, i7 6900K. i7 6900K. Page size. Max memory size. my computer right-click properties right. Okay. I want to see the memory. 8 by 32 kilobyte, 8-way associative instruction caches. So you have 32 kilobytes. Right, L1 is the fastest. Agree. I am trying to optimize almost entirely for L1 here. Eight cores with 32K each. Okay, that totally makes sense to me. And the 8-way set associative, if I remember correctly, way bigger than 64 bytes. So it has to do with actually going to the memory to get the data and sending it back over to the processor. You thought I knew all of this. You end up loading 64 bytes at a time. It's when okay, when no, I totally understand that you have probably done this and you can help me with this. My understanding of all of this is that when you are going to evict a page of data, where there's like no way in our 32 kilobytes we only have like 8 pages of data in L1, and then it all gets evicted whenever we go and load something new. It's not throwing away an entire 4 kilobytes. It's my understanding that at any given time, you can bring 64 bytes at a section into its own place. And then when you need to evict something, you are only evicting 64 bytes at a time. Now, when you're evicting it and you need to go to level 2 cache, if you're going to load something from level 2 cache, then it's going to have to be very near where it was in the previous one. But I just don't remember it being very large at all. I would want to just say 64 bytes. And now you definitely have me second guessing myself. Cache is its own address space, so memory pages in the OS aren't associated with it. Right. I'm not entirely understanding what you're getting at there. Okay, there we go. All right. Things are generally 64 bits or less cached per value cached in L1, L2 on an individual basis. In terms of... I'm not entirely sure what you mean there either. So you store a float or an int. So the processor doesn't really care whether you have like a float or an int in there. It's just bytes, and the bytes are aligned to some memory address. And you can say, if I want something from this memory address, it has to go and load this page. And then it takes whatever it needs from that page, and it might go and load additional pages after that to get whatever else that it needs. But it doesn't actually care what's in those bytes or how they're aligned or anything like that. You're just saying, I need something from this range. And so, if I'm wrong about what I'm trying to optimize for, I definitely don't want to waste time on this. This is not going to be like a fast thing here. So cache and memory byte alignment are different. I totally understand that. But I don't see how that's affecting what it is that we're trying to optimize for here. Uh, yes and no, assuming we know what the cache size is. So, okay, this is a good point. At this point, we are building a solution for a very specific machine, right? I'm not building this to like be generally available and work anywhere. This is going to run on a very specific server that has a very specific processor, and all of the configuration is totally under my control within my data center. And I need that to be fast. Just that one use case. This isn't like I want somebody else to go and download this and it's going to be fast for them. I want this to be fast for just me. So my understanding here is by using Intel vTune last week, we came in here and we identified that the slow part of our decision tree is literally in stuck loading this and in loading this. And there's a little bit of an issue right here where I can't seem to force this into a conditional move. Instead, it just keeps doing a branch. But it's not the biggest issue. The biggest issue is combined these two things loading from memory. So the idea is that we are looking at the trees, the decision trees that these are coming from, and they're loading features from all over the feature space. And so what I want to do is I want to compact this as much as possible so that any given tree needs to touch as small a range of this as possible. The alignment matters at the point where this is in memory to some degree because at some point, you know, you have to load different pages in order to pull this stuff in. So yes and no in a sense. I have the trees. All right, this is a great point. Let's go over what I've done so far. What I have done is I've taken the trees and I have expanded every single possible path through all trees. There's 1,000 trees. They have a maximum depth of 6, so if you include the leaf, 7. And I want to say that altogether, the total number of paths through all the trees is somewhere in the 26,000 possible paths range, with a maximum depth of 7 or 6 or 7. We'll find out in a second when we run it. The idea is that I wrote some small code to sort of guess how many pages of memory it's going to take to load these up, and this should actually be 16, but to guess how many pages of memory would have to be loaded in order for an entire tree to be evaluated. Then we pass every tree in here, we sum it all up, and now we have an optimization problem of I want to reduce the average number of pages it takes for any tree to evaluate. That's the goal here. Something, when we run this and we run it through the profiler, something like, where is it now? Something like 70% of the time is stuck on these memory allocations, or not allocations, on these memory accesses. And it's my understanding that that's happening because they're just dispersed all over the place and we're basically in random access mode. Did I explain that well enough? Also, thanks for stopping by. I hope everything's going good for you. Does it make sense what I'm doing? Or am I wasting time here? Because I definitely, this is going to take like the vast majority of the rest of the day to get this right. Okay, so this is a boosting model. This model was trained in R. It was originally a random forest. which is just a bunch of decision trees. And then we had some real issues trying to set up an API for it that could actually do this. Oh, to tell you what I'm actually doing all this for. So I work at Stack Overflow. Oh, I got to turn off my ad block 1 second. Login, Raspberry, disable custom time. We'll just do 60 minutes. Okay, so if we go to Stack Overflow, on the side here, we see these job ads. Can you see this? No, here, they're up here now. All right, we have these job ads. And for each, when I come to the page, there's a cookie on here that like knows that I've been here before and yada yada, et cetera, or it has my account ID. Okay, great. And so what we do is we take all of the user information, and then we, for every single job, we take the user information, merge it with the job information, run it through basically a model to get a probability of a click, and then we use those for weighted stuff later on down the line. So this model that's currently running in production is like years old, and this is the real problem. Is it's like kind of fallen out. A lot of the things that are in here, it never gets retrained either. So a lot of the jobs that exist today, even things like React, things that are just like super huge and there's tons of jobs out there for it, we do a really horrible job of targeting for. So the goal is to come up with this new model. When we retrained basically the same way that we did the old model, which is just a huge logistic regression, we did not see an improvement at all. And in the one test we ran where we did see an improvement, we had like just basically lopsided it. We helped a bunch of jobs and we hurt a bunch of other jobs. And so we decided not to go with that because it was just hurting way too many of our jobs and we didn't want to have too many upset customers. So instead, we came up with a new model, just throwing it out the window and saying, okay, just everybody go and try whatever you can think of. And the one that ended up winning was a random forest. We tried to set up an API for this because we did not have any code in C# that was going to be able to evaluate this stuff. So we're like, okay, this was trained in R. We'll just set up an API in R, and then we'll just host this like internally on our own little stuff that we have for our team. And then that's what we'll use from now on. The only problem is when we started running it through R, it was ridiculously slow. Like to run a single job and user combination through just one job was taking anywhere from like 1/100th of a second, so like 10 milliseconds, to up to like 200 milliseconds. I mean, it was atrociously slow. On our job board right now, we have something like 6,300 jobs. And during some experiments that we run from time to time, we've had as many as like 12 to 15,000 on the board at a time. So what we've done is we said, oh, we also have a timeout. All of this evaluation has to happen in order to show a job. And this was a bad example. Nope, I'm in the wrong spot now. Need to go back. All right. All of the calculation for this has a time limit of having to execute in 100 milliseconds. If it takes longer than 100 milliseconds, we just don't show an ad, period, on the page, in favor of just showing nothing. So instead, we have to speed this thing up enormously. So we set some requirements. We said it has to do 10,000 jobs. It has to do its single core. We can't do like multi-threaded here because if we do multi-threaded, we're just going to destroy our web tier where all of this is running. It has to be single core, and it has to get done in somewhere around like 50 milliseconds. There's a lot of other stuff that goes on around like picking, the creatives and stuff. Like this has a creative of remote jobs, and if I refresh enough, it'll start showing me other ones like looking for a job, and there's all kinds of other stuff. Determining what crap in here to show, all of it. Whatever. And so, yeah, we decided, okay, we're going to just implement this in C#. We switched it from being a random forest to a tool called XGBoost, which is basically like a boosting wrapper around decision trees. Works almost exactly the same. as a decision tree, like the implementation would not change very much at all. And so the idea is we just have to implement this, and I have to get 10,000 jobs done, 50 milliseconds, single core. Those are my requirements, and that's what I have to work on until we basically figure it out. To show you where we're at right now, we're doing 10,000 jobs. We're doing it. Let's just do the decision tree test real fast. I have to run it in. I have to run it like this. CD. I have to run it in production mode, or else the timings don't mean anything. And what this is going to do is spit out a little output file here that shows us that we can do 10,000 jobs single core in about 226 milliseconds. To get deep into this, I think you're doing this kind of backwards. Okay, I am all ears. Like I said, I have requirements. I don't have any specific way about going about doing it. Sounds good. I'll be here when you get back. In the meantime, I'm going to continue driving forward as if this is the actual problem, and then see if we can make some progress. All right. Feature reorder. Okay, so in this program, all right, so we are basically generating all paths. You know what? Let's go ahead and do this. Dot first. Dot take one. So I'm going to generate all the paths for the first tree. Then we're basically going to look and make sure that it's correct. And we're going to do that by basically walking through it in here. So we start here, and then anytime we get to a leaf, there should be a new tree, because there's only one way to get to any leaf and a tree. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there should be 17 trees. I'm sorry, 17 paths that pop out of this first tree. And then we're going to basically just take a look through each one of them. And see if we can figure that out. F9. And then I want to set this as the startup project, and I forget how to do that. I think we have to go to solution. Solution. I don't see anything about a startup project. Post solution, pre-solution. Yeah, I don't see anything about a startup project. Okay, great. So maybe we just go to VS Code, launch. And BLOS. To start looking at your jobs and users, I think that reevaluating things during page build is the wrong time. I think you have more time to work on things when the job or user are created. So you can just queue up evaluations and let them happen. Then, during page build, you don't need to reevaluate everything over and over. Lots of wasted work during page build otherwise. So sort of. Yes and no. The there's a lot of things that happen. Basically, when you come to the page for the first time, and you are not a logged in person or anything like that, we cookie you. And if you're on a question, like for instance this one, well, no, let's do a better one. Let's do something like this, right? What we do is we start taking everything that we know from the question and try to sort things to you already. So in order to take every single question and pre-calculate what we should show for every single job, and then when a user comes, we still have to weight each of the people by how close they are to the job, because in every single experiment we've ever run, how close you are to the job is like the most important thing, period. So at some point, we still have to do work for every job for the request at hand, because we don't know where they are until we geocode their IP address. So there is an enormous amount of pre-calculation that we can do for some things, but we still have work to do on each one of these. And oftentimes we don't know anything until it comes. Also, jobs are being posted pretty much all the time. Every 5 minutes there's a sync that happens in the background where all of the job data gets shifted over, and in 5 minutes I have significant, well, I guess you don't have to recalculate it for every job, but you definitely have to recalculate it for every job that was updated in some important way, something that would affect the model. And any new jobs you have to definitely update. But I still feel like for the most part, we have taken care of the majority of all of the pre-calculation. If you give each job a weight based on the user, then when you have the tags from the question, you can filter down to jobs matching tags. So we don't do it like that. There are some jobs that have no tags that match anything on Stack Overflow, and you would completely destroy the number of impressions that they get. So instead, what we do is calculate a like percent chance that whoever the person is that's viewing is going to click on this job, and then we use all of those basically predictions and just do like a weighted random selection between all of those. Okay. If you have changed frameworks, search problems, I guess I just want to make a new one and put in instead of it being BLAS, we want it to be console app. Workspace folder, console app, bin release, net core app 2.2, console app. Just make sure that it is called console app. Oh, fast.console app. And then if we go to bin, we go to release, net core app and then it's fast.console app. I was meaning the weight is the probability to click, the output of user plus job into the model. My glossary is often different than folks expect. The tags are just keywords or actual site tags, either way. I mean, if you give each job a weight based on the user, then you have to... Okay. I was meaning that the weight is the probability to click. Right. Right. Yes, all of that makes sense. Okay. Yeah, there is a lot of room for like this. That's what the fun of all of this is right now, is figuring out the optimizations. Like, we know all of the job stuff up front, like prior to a user ever getting here. So there might be a world in which we can like pre-take all of the branches for each job when we know those features. And then instead of these trees being, say, an average of 6 deep, they might be an average of 2 deep or an average of 3 deep or whatever it is. But that could be like a huge improvement in the amount of time that it takes just by doing that pre-calculation. That, of course, does come with some like additional side effects of now we have to store trees for each job as opposed to one set of trees. So there's a lot more memory in use here. And I'm not sure, since solving memory access is the problem that I'm attacking right now, I just have serious concerns about whether or not that would be a huge improvement or not. So you see JSON in the question and JSON in the job, that's a match, etc. That's what I'm suggesting. Something like a Spark-driven async system. When a new job is published, it gets evaluated, scored, and tagged. I mean, the learning step was like done by the data scientists here at Stack Overflow. So the model that they have given us is the model that like I need to implement. Like, if it found that JSON questions and JSON tags on the job and the user like history is important, then that's a thing. But that was not my job to make. Doing it at a different time in the timeline of usage on the site. I mean, I understand what you're saying. There's just there's a limit to how much pre-calculation can be done for this. And everything's a trade-off. Like, the more pre-calculation we do, the more memory we end up using. And there's a limit to both of these things. I mean, the memory side of it, not that big of an issue, really. We have, 10,000 jobs, and even if we're storing, like, a megabyte per one of these, well, I don't know, you couldn't really churn through 10 gigs. So maybe a megabyte's way too much, but, like, say a kilobyte, something like that. If you had a kilobyte, even 4 kilobytes per job, like, that's not the end of the world. Yeah, it's not really the end of the world, but I'd have to see it be valuable. There is a filtering step that happens for a lot of users based on where you are. A lot of jobs only allow you to see the job if you're in the same country as the job. That sort of a thing. So there is a lot of stuff. I know you're trying to help, and all of the stuff that you're saying is definitely like stuff to think about. Some of it I have thought about before, and some of it is definitely still interesting to me. There is like a limitation to how much like re-architecting of everything that I can do. Yeah, exactly. Site speed to me is often more important than how much memcache gets used to keep page renders fast. Yeah, I agree with that as well. I'm just saying that like churning through memory seems to be the issue right now. Although, churning through sequential memory would be a lot less of a problem. But yeah, churning through memory seems to be the vast majority of the... Actually, that's a good point. I'll think about it. if you had a different set of trees, no, you'd still be accessing random places in the feature vector, which is what I'm trying to eliminate. Yeah. I mean, speed really is the only thing that matters right here. Whatever is, everything is on the table. Like, that's what it comes down to. There's no way I can pre-calculate all the users for all the jobs up front. Like, there's just no way. I can't even really group them. Well, I take that back. I could group something like anonymous users that we're seeing for the first time, but that only makes up like 10% of our visitors. For users that come back often, they are cached. So non-anonymous users, all of the scores are cached for, the 5-minute duration. And then they're recalculated when they come back after 5 minutes. Yeah, there is a lot of stuff going on there. I think kind of a little bit. I think it's cool though. I'm totally about it. Like, this is why I enjoy doing this stuff on stream. It's not just me like, churning through it. Like I said, all ideas are on the table. Big re-architects, maybe a little less on the table, but if turns out we can't get this to where we need it to be, I mean, everything is actually on the table. It is a deep search. Yep. I mean, there's a lot of hacks that we can do for this. So I can't show you the analysis from the data scientist, but there are a lot of things that we could do for this without sacrificing a lot of positive predictive value, which is like the only thing that we care about as far as a metric on this. Meaning guessing correctly the people who are going to click and not worrying if we mistake the other ones. What are the trees versus the features? So the features are things like how many times has a user, no, what percentage of a time, what percentage of a person's question views are for a certain tag. On the job itself, it's literally the entire text as like a bag of words, of the description, of the title, of the tags, and each of those things is stored as its own separate bag of words. So the total model itself, like the input feature space, has something like 840 features. And the training was done on, I don't know, something like 2 million samples. The trees. What are the trees versus the features? Yeah, that's the features. The trees themselves, couldn't you put those into a new model and let a tiered neural net wait? We had that done. So like I said at the beginning, we all took different approaches to model building. The one that won was basically a decision tree model. And when I say one, I mean in terms of positive predictive value, which is the metric that we basically made our decision off of. How good are we at guessing the true positives effectively and not caring about anything else without sacrificing accuracy mattered to some degree. There was an analysis. That is beyond my skills. So I did a logistic regression. Another guy did a neural network, and one other person did like 3 different models. And the one that, between all 5 of these that ended up winning was the random forest, and it was like a notable improvement over the remainder of them. And the ones, like, everybody took lots and lots of different approaches, but it's like way beyond the scope of me actually getting anything done today to talk about all of them. They were super, super interesting. We had like hours long discussion over how they all worked. Yeah. I mean, at that point, like, we're just a little bit beyond, like, this is my job right now, is to implement this XGBoost model and get it ready for a production run so that we can run a test and see if it was actually better. So that's what I need to work on, and everything's basically going to stay on this path for, well, until we get it done, unless there's just no way we can reach the no, I would love to sit here and do this. I absolutely would love to have this conversation. In fact, I'd love to have this conversation in person and like have you on the stream, and like we could talk about it and go back and forth and really get into the nitty-gritty and the details. It's just right now I do have to work on this. All right, fast.console app. That's my workspace folder. Let's see if this works. Build. Console app. What happens when I press play? Yay! Show errors. Project or file does not exist. What? Console app? Fast.console app. Is it this one that's complaining? It's been so long since I've actually pressed that play button. I should probably just open this in the other one. Let's do a... Where was it? Task? Build. I don't really want to do that. I just want to build. Workspace folder? I'm just going to do workspace folder. Like that. Let's try that. Build. Okay, well, we solved one problem. All right, 10,000 evaluations, 255. All right, so this is elevated a fair amount, which is frustrating. I don't actually want the debugger. How do I get rid of the debugger? I don't want a debugger. Stop at entry? What if I don't want to debug it? Yeah, I don't know. Whatever. It's not super important. Hey, what's up, Hugo? It's going good, man. Just trying to get back on this. So today we're focusing on, we're making a huge assumption that there is a lot of problems with loading this and this. So last Friday we took a look at some disassembly in Intel VTune, and it showed that like 70% of the time was stuck on here and on here. And so I'm trying to figure out if we can reorder features to show an improvement. And that's what I'm getting at right now. So the idea here is expand all possible trees, and then just first verify that I'm doing that correctly, and then come up with a metric to see if we can reduce the number of memory pages that. Oh, great. Oh, that's cool. Okay, perfect. So yeah, we're just finally getting around to actually working on that now. That's what we're doing. Yesterday, I actually got started on some of this and actually wrote some of it up, but I am in here now to try and verify that this is doing what I hope it's doing. And so far, it doesn't really appear to be, frankly. It's my short answer. I really thought this console app thing was going to like start and then it was going to output something interesting, but instead it ran test, which is not what I expected at all. This time taken? No. Right? I don't understand that. Terminal? It's like literally doing this timings thing. Maybe I just need to build. Or maybe it's running it in debug. I just really don't know here. Wasn't sure what would... that's what I was thinking too. Basically, the tree object instead of referencing array elements in an index, but wasn't sure what would happen with structs containing structs. I don't think there's a whole lot of difference. Is there? I don't know. My only like real concern with that is that you're now going to be calling basically recursive functions. No, your evaluation structs instead of structs, so it would load it directly. So it would go directly. Oh, I see what you're saying. I see what you're saying. So instead of basically taking these indexes, this would just directly return the next node. So there's no need for this node index anymore. That is interesting. That is interesting. Maybe? So let's put that on the list. To do. Try removing array and using object graph. So that is a very interesting thing to try. I don't know off the top of my head if it's going to have anything, if it's going to help or not, but I'd have to think through it a bit more. Right, yeah, right now I just want to see if this, like, I want to see if it is possible to reorder things. Because if we can reorder things, we can get a lot of win. We can get a lot of win because we can greatly improve this, and then we can also reorder the order in which we evaluate the trees to minimize the number of, like, memory pages we have to look at as we go through the trees. Ideally, we'll see. Yeah, let's just go and take a look. For some reason, this is just not doing what I expected right here, like at all. Somehow it's still running this. Maybe I just need to build it. Problems, output, terminal. Great. Command. Let's go with a .NET build C release. Okay, and then let's see if this works. I mean, I don't know what's going on. I mean, that looked like a build to me. And it's, why the hell is it doing this? I don't understand this at all. launch. I am literally telling it, go run this release. Oh, you know what? It might be that I'm compiling in 472. Console app. Close this. Console app. No, I'm building in Netcore 2.2. What in the hell? I have no idea why this is not running what I want. So instead, we're just going to print out the trees, I guess. I really just want to pause it. Let's go to program and let's just put a little breakpoint in there. Wow, it didn't hit that at all. It did not hit that breakpoint. Am I losing my mind? I must be losing my mind. I must be. Nope, that's not helping me. I don't want that at all. Great. Debug console. What is going on? What if I just go and delete the build folder, and then we're going to know the answer right away? I like that idea. Delete. Delete. Let's try that again. Oh. So that's not building at all? Open launch.json. Cancel. Okay, so terminal. Oh, console app is not... No, there it is, right there. It's building right there. Restore completed. Build completed. Why is it building in debug? Because the build itself is not building in release? Alright, well, at least this is starting to make sense. What's selected in that combo at the top? Great question. This. Configuration. Go to this. Oh, yeah. It's in here. It's in here. Task. I need more build. And now I need arguments, which I believe are -c release. Let's try that. Pre-launch code exited with code 1. Show me the errors. That's great. Okay, how about we do that? Oh, there we go. Okay, all right, we are making progress now. Okay, so there are 17 paths, which is exactly what we would have expected. Okay, great. We're on the path. Ha! See what I did there? Okay, so this is now building and release. I wish it was sort of like you could choose. Maybe I have a build and a build release. Let's do that. Build release. And then this build one, we get rid of this. And then we go to launch.json. And on this one, instead of build, we do build release. Can you see the data again? You mean the tree data? This is the tree data. Actually, You can, this is all up on GitHub. Let me get you the link. GitHub.com. This is in datasets, XGBoost. There you go. So do you need the stuff beyond? You need the yes, you need the no. Those tell you the index to go to when this is true or when it's false. When there is a leaf, then you just return. These cover things, the gain doesn't really matter, that's just informational. Cover tells you how many nodes there were, how many samples were in the training when this was trained on, and how many made it to this leaf. Like how many samples there are at this leaf or at this node or etc. all the way down to whatever. Missing, because the way we handle missing data, we always treat it as value 0. This always ends up going to the yes side because all of these values turn out to be positive. Oh, Friday's updates weren't committed. Well, I'm sorry about that. They are committed now. These are valuable in some way. What you can tell, for instance, is that this percentage, this divided by this percentage of samples in the training data made it to this leaf. So if you want to like weight this path, for instance, that would be a way that you could weight the path. The gain, though, yeah, you're not really going to get anything by the gain. I'm not even sure like what metric for gain it's using. I'm not sure if it's like Gini or just raw entropy or what it is. Okay. Back to the game. All right, this thing is finally doing what I want it to do. We found 17 paths. That was correct. The average path length is 5.76. Okay, I believe it. The average page count is 3.11. Well, I also believe that. One of these paths only uses a single one. That would be the first one. 12 of the paths use 3 separate pages based on my heuristic estimate. No, all of the trees have different ones. This one is F0. If you go down to the end where the boosting really starts to kick in, or maybe I'm wrong. Yeah, see, like this one right here, once the boosting really starts to kick in, it starts to kick on other features pretty early on. Hey, what's up, Mike Jolly? Okay. All right, so I feel good that it's creating the correct trees, but always at index 0 for a given algorithm. No, it just so happens that we put the most important feature, which is distance from the job, as the feature at index 0. If we had just happened to put distance from the job at index 273, the feature that it chose would always be 273 in that case. It just happens to be that we chose a really important feature to be feature index 0. Just randomly. All right, so we get this, we get the average path length. We are now counting these. Now what we want to do is say the average page count is 3.11. And what we want to do is reduce this as much as possible. So we're going to call this thing called the feature reorderer, and the first way we're going to go about it is with a greedy approach. And then we're going to write out whatever we get to a file so that we can use it to see whether or not we're actually better. So this greedy approach, in the greedy approach, we get all the paths. We create some node lookups. And I know that there's a bug with this because I was running this last night, like in bed at way too late, and it was coming up with some really dumb results. We do node lookups. The node lookups make this enormously faster. Then we say features. How many features are there is basically what we're counting, because we're just counting the feature index. We're taking the max feature, filling in all of the ones with a blank feature. Then we're saying this is our metric, basically. We're saying, give me the current one. How much does it take right now? Treating that as the best. If we don't see... Hey, what's up, Codebase Alpha? If we don't see a... if we don't see an improvement within 1,000 tries, we're just going to bail. For each of the features, this is where the code really starts to get ugly. For each of the features, we're going to... That's what we should do. We should do this on one first. We should try to improve a single tree. And if we can improve a single tree, then we should do it for 2 trees, and we should try to improve 2 trees. Okay, I'm starting to like this. This approach is much better. Let's just do tree count. Tree count. And then this is going to be dot take tree count. Okay, so we're choosing the very first feature index, 0. We're choosing anyone that comes after it. These I don't want anymore because I should have taken care of that problem. Then I'm saying go to the node lookups, get me the nodes that are currently at that index, and then I'm saying each of these nodes at I needs to have the new feature index of j. And then I'm saying all of the j features need to have the feature index at I. That's a swap. Is that correct? I really just want to debug this. So let's do that. Errors exist after running pre-launch task build release. Yeah, show me the errors. There is no argument given. Oh yeah, that's true. I didn't update that, did I? Program greedy model 1. Okay, let's try that one more time. Why is it finishing? I really want to debug. Like, how do I put it in debug? Do I have to like build it in debug? Let's do release. And let's do debug. Debug. Stop at entry. If true, the debugger should stop at the entry point of the target. No, I just want to stop at when I run into a problem. Release, debug, build. Hey, all right, there we go. Great. Do your thing. Get the model. Do all this crap. I can just undo this, and then I can press play. This is where I want to stop. Greedy. Great. Doing greedy search. Give me all the paths. There are 17 paths. Hooray. Do my node lookups. For this, whoa. Node lookups should have a whole lot more. Raw features. Ooh, I need to filter out -1 there. No, not really. I've got max. Okay. One. Features. That -1. Oh, I see. I see. Feature index. Features. I don't actually use features anywhere, do I? Just to get the max? If I only care about getting the max, the hell do I use features for? Oh. God, okay, here's the bug. Okay. So, features, I don't actually care about this. I just care about max. I'm going to call it features max. I don't even care about distinct. I just care about max. I'm going to call this features max. And then we're just going to call this features max. Okay. Great. Let's restart. Actually don't even care about any of this. Features max 762 sounds good to me. Yep, we're just gonna play because that's gonna take forever. Now node lookups has 764. Great. Features max 762. Huh. I want to say dot where m dot feature index is greater than or equal to 0. I want to redo that. Don't care about that. Okay, so now we have features max 762, node lookups. Why is that 763? I also need this to be less than or equal to. So somehow this is getting feature indexes that, well, they should just never really be hit. The only problem is let's just take a look at this one more time. All right, node lookups, 763. Okay. That's sort of interesting. Okay. Take our metric. Our best is 3.11. So for features, why is it doing that? I really don't get why this is coming out at 763. Oh, yes, I do. 762 is the max value, and it's inclusive. It's 0 indexed. Okay, that makes perfect sense. Okay, that makes perfect sense. Okay, so 763. That should never fail. That should never fail. If there are features of 0 and 1, node lookups, feature index 0, original index 0, 1, 1. So basically all of these should just be 1 to 1. I shouldn't even need this to be like this because these should all be shared. Maybe that's the problem. FPGA. Like a hardware device? That would be. I'm not sure we're going to get that one implemented. That would be cool. I actually have a buddy of mine that I went to school with who does that for a company out of Blacksburg. He's tried to get me interested in that stuff before. I should take a look at that. How does it hook up to a computer? Like, do I have to send something like out of a USB port? How long does that take? Or is it something that like plugs right into the bus? So there should only be one of these if we did this correctly. Because they are shared. Let's see what happens when we expand these. Yes, they are shared. Okay, so this should actually be not to array, this should be single. And if this doesn't fail, then we can just do this. And then this becomes a whole lot faster. Nodes I. Nodes J. And then that is actually doing the swap here by putting J where I used to be and putting I where J used to be. And if we're not going to keep it, then we can just, I think this is the entire step right here. I think we want to set I back to I and J back to J. Feel somewhat confident that's the actual problem. Select mini node lookups. There are not select mini. We just want select. Then I want to say that this is still true, but I think we get what we want by just going straight to dictionary. Hey, Rhyolite, thank you so much for the raid, man. I really appreciate that. That's awesome. I hope you had a really good hope you had a good stream today. What's up, Falco? We're taking a look at we are taking a look at speeding up some decision trees, and right now what we're doing is trying to reorder. Yeah. Yeah, right now what we're trying to do is reorder the features that are going into this model, which is basically like a random forest, effectively. It's just a bunch of trees, to see if we can improve the cache locality and speed this up. We have requirements on the speed to get it to be able, on a single processor, to process 1,000 trees that have a maximum depth of, I don't know, 6 or 7. And we have to get through 10,000 iterations of all of these trees in like 50 milliseconds. Right now we're sitting at about 220 milliseconds. And so that's the problem we're working on. Right now what we're doing is approaching it. Thank you so much for the follow, Arik J. That's the best I can do there, I think. Arik J. I think that's right. Really appreciate that. And I think that there is like, no, this is one idea that we have. And we've got quite a few ideas that we're working on to see if we can get through this. Thank you so much for the follow, DDuck003. If we can get through as much as possible, as many of the ideas as we have, I think we ought to be able to get there. Like conceptually, a processor can get through that much in that amount of time, so I'm not like super worried about it. Worst case scenario, like we use fewer trees, because right now we're using 1,000 trees, or we cut down the size of the trees, and none of this will sacrifice too much on the overall like predictive value of this model. So hopefully we'll get somewhere usable pretty soon. Right now what I'm doing is debugging well, we're using a greedy approach to reorder these things, and we have a metric that we're using to calculate, to say like, okay, is this an improvement? Is this not an improvement on reducing the overall or improving the overall page locality? And then once we get to, or we're using a greedy approach of literally just swapping effectively random features until we stop making improvements. And if we get done with that and we notice an improvement, then this is an indication that we should spend some more effort on not only reorganizing the feature order, but also reordering the trees a bit. And that's sort of where we're at right now. But yeah, I really appreciate you dropping some people off, and hopefully y'all will find this as entertaining as it was for Rhyolite. All right. Stop this and try this one more time. Single. All right, so I did screw this up. Sequence contains more than one element. M. No. Distinct. I would have expected distinct to... Oh, no. You can check the same feature index multiple times. Right. Okay, so we're going to have to undo this. I still think this was the problem, but we'll come back to that in just a second. To array. Okay, and then this being the problem is that this should be I and this should be J. All right, all pass average. Great, so we got through here. We now have our node lookups. Which ones of these have more than one? Okay. Now we check that. Was it an improvement? No, it appears to be about the exact same. No, it is. It is different. Look at that. It is different. Which doesn't make any sense. That's just got to be like rounding error. Okay, we're just going to let this run and see what comes out. Exited with code 0. New best. Ooh, that is an improvement. That's great. Now let's see. It should have written out a file. Where would it have written out a file? To reorder.csv. Okay, so it swapped 1 and 17. And basically what we need to do is see if the rest of these line up exactly, and unfortunately there's 700 of them, so it's going to take a minute. Oh, that's not good. Okay, so somewhere it started shifting them. No, it didn't. It's not indexing them at 0. Okay. Is it possible to make this index at 0? That would really help me here. Without like a plugin, of course. 101. I'm basically looking for like missing stuff on the sides. I think this is actually gonna work. $762. Okay. Now we're gonna try it with 2 trees. Right here. And see if we still have improvements. So this was the average page count. I guess we could do this like sort of printout thing again. In your write to log function, could you include an extra numeral write to log? On which line? Are you familiar with how to use the bang line feature here? Have this right here. Twitch highlighter. You can use bang line and then the line number. So let's say like 37. And what it will do is it'll actually highlight it here in my code so you can draw my attention to it. And then if you want to unhighlight, which is a nice thing to do once we have done it, you just do bang line number again, and it'll remove the highlight. That was something that Clarkio set up. He's another streamer here on Twitch. Oh, I meant in your CSV file, you want a reference from 0. Oh, I wanted the line numbers to start at 0. So if we go up to the top right here, this is like a line number in the editor here. I wanted this line number to start at 0. I guess that doesn't really make sense. Could add a number. I could just remove the 0 from the actual file, the CSV file. Let's see. If I just go like that. Okay, yeah, actually that works. Okay. No, I don't want to save that. All right, we're going to see if we can do this with 2 trees now. If we get it to work with 2 trees, but I do want to write this out again. So I'm going to basically do this. New best. And then here we're going to go with this again. So this is not the same model because it's building a new model. So I need to actually like perform the remapping in order to test this again. So we're gonna bail on that for a second. Put a little to do there. Perform the remapping. And we'll come back to that. The remapping is not going to be that hard to implement. We're sort of already doing it inside the feature reorder. So we might want to, from here, I do want to return the mapping because I need the mapping in order to reorder the features when I do my testing. Okay, so I do want that. All right, we're going to try this with 2 now and see if we show an improvement with 2, and then we're going to bump it up real fast after that if it does work. Hey, what's up? Hey, Mary Page 11. We can stop debugging. Okay, with 2 trees, I didn't do 2 trees because it did not change it from 17, so that's bad. So that's bad. Why? Program 2 trees. Ooh. What if I do like 10 trees? 10. Is my debug console just not working? Oh, there it goes. Lots of improvements. Look at that. Okay, so this time, oh, I see. It's because up here I'm doing this different. I'm saying take 1. So we're going to do const int num trees equals 10. Num trees and num trees. Try this one more time. All right, this time. Okay, we went from 3.46 pages on average per path to 2.14. That is I would call that a fairly huge improvement, personally. So let's bump it up. I mean, I don't have any other way to say it. Let's bump it up. Let's get it going. Let's go with, I don't want a const anymore. Model.trees.length. And hopefully this is going to print out something. Oh wait, no, you know what? We did 10 trees. Let's see if the CSV that it's creating is still correct. First off, does it have the correct number? 824? Probably. Okay. I need a way to verify that each of these numbers shows up exactly once, which we're going to do in the program. That's what we're going to do. We're going to say var valid file, valid reorder equals greedy reorder map dot select m dot we basically want to make sure that every number shows up in here. So we want to make a hash set. Yeah, that's it. Let's do that. Let's do var all features, feature indices, indices equals new hash set. So the idea here is we're going to create a hash set of all of the mapped features and make sure that there is exactly the number there's supposed to be. Short. And this is going to be greedy reorder map. And then what we're going to do is we're going to say for int I equals 0, I less than. Maybe we're going to do a short here. Short I equals 0, I less than how many of these should there be? Greedy reorder map dot length. Greedy reorder map dot length. Okay. Less than or equal. Yeah. I plus plus. And then we're going to say if not all feature indices dot contains I, then yeah, throw new exception. This is not valid. The thing, it's not a thing, the reorder mapping is not valid. And we're going to go ahead and write this out to a string anyway, just so that we can go and find what it is. Probably don't want to throw here. Just do a console dot write line. And then let's give some information. Not found. Not found. Index plus I. Break. Okay. Okay, let's try that. This is probably going to take a minute to run, maybe a few minutes. So in the meantime, if you have any questions, feel free to ask. In fact, I think that'll go a lot faster if we don't do this one in debug, but if we do this one in release. All right, there's some improvements. So our average page count per tree is about 4. Oh shit, what the hell happened? 4.35. I have no idea what these little bitty improvements like actually turn into. This is silly. I'm not going to run it like this. I'm going to run it in a terminal. We don't need to have a debugger attached. We're just going to do cd ... space console fast.console app .net run c release. Hopefully this is faster. Goodness, it's not faster. Improvements are... So the way that it's doing it right now is it is starting at the 0th index, and then it's saying... No, the 0th feature. And then it's saying, let's swap the 0th feature with any one of these other ones and see if there's an improvement. And if there's an improvement, we're going to leave that one, and then we're going to keep looking at all the other features to see if we can swap it with any of the other ones. Then it moves to feature 1, does the same thing. Can we move this anywhere and make an improvement? And once it no longer finds an improvement, all right, well, that wasn't such an improvement. I think we need to let it run for a little bit longer. Maybe 1,000 is kind of an early cutoff. Feature reorder, let's do a cutoff of 10,000. So it has to get through 10,000 trials before it will bail and say there's no improvement to be made. This is one place, this like really brute force kind of way of going about it is not super fast. I think we can probably make a lot more improvement by doing some quick analysis. And saying something along the lines of, for every pair of features, well, this seems to be going faster, interestingly. For every pair of features that we find, can we estimate how much of an improvement would be without actually calculating it? It would be... Okay, we look at all of the trees. No, we look at all of the paths, and we see how many times the same pair of elements show up in the same path. The same features show up in the same path. And the ones that show up the most together, we try to get those on the same page. And that is the greedy step. And when we run out, yeah, I don't know. This seems to be making improvements. I have no idea how far this has to get before it turns into something like valuable. Hopefully, even what it's found so far is kind of going to be a big improvement, right? We're basically shifting these numbers down, and the goal is that we shift them down enough to make a notable change on page locality. So to go from 4.35 to 4.3, that doesn't seem like that much, huh? It's still finding better ones. Let's just let it roll. This is kind of a crappy way to go about it. I would definitely want to find a better way, but at least we only have to do this one time per model. Like once we have this mapping, we can just remap everything and we don't have to worry about it after that. It's finding a lot of improvement here. I would love to see this get down to like 3.5 because then I would know that there has been some fairly significant changes. Oh, it's making some jumps. This is going to be the boringest thing ever watching this roll. There are so many times in my past though where like I would create like a game playing bot and then I would watch it do basically this, just numbers scrolling as it like plays itself just to see like, oh, is it getting better? It's frustrating because it's kind of difficult to estimate how much better it's getting. Yeah, but I know that if it goes to like 3 point, even 9, if it gets to like 3.9, like there's going to be a fairly notable difference here. The reason being is in order for this to get to 3.9, you would have had to have switched what? There are 27,000. Actually, we can just do this. How many are there? There's 25,744. 25,744 times 4.354. 3.354. 354 equals. Okay, so 85. I'm just going to copy this. Let's drop it somewhere in here to do. Okay, that's one number. Then the other number is, if we go all the way to the bottom here, if this were to get to 3.9, we had 25,744. 25,744. 25,744 times like 3.9. The hell? How's that a bigger number? Must have done the other one wrong. Clear? Did I not clear it right? Clear. Times 3.9. Okay, I did the other one wrong. And then we have this right here. Clear this times 2744 equals. Okay. So total number of pages of memory that we think we would have to load, we have already reduced by what, 10%, 9%, something like that, which is not a small amount. Or, well, no, we haven't gotten there yet, but if it gets to 3.9, 3.9, I would say we would be able to see that when we do the run. Oops, 4 point something, 4.35ish, 354, I think. So yeah, this is gonna be kind of boring. I don't want to stop it until we get further along, because I don't know. Also, I can't stop it because it's not going to freaking save the model, the reordering, until I'm done. You know what? I think this might be the end of the stream because I just have to let this run until it stops. Basically, okay, what's going to happen? This doesn't need to be the end of the stream. What's going to happen next? We have a reordering. So let's create the function to perform the reordering. greeting. Public static. I want to say XGBoost. I don't even need to do it like this, do I? Yeah, XGBoost model. Reorder. And we want XGBoost model, and then what we want is a short array of reorder mapping. All right, so what we need to do is create a new XGBoost model that is the exact same as the one that we have, which I can't do because I think the right place to do this is going to be inside of here. XGBoost model. Because I need the trees. Okay, I can get the trees out. Another method I was thinking about, but totally no idea of impact, is to flip the execution so the method is in the struct within the array. So it's not assigning objects within a method, but instead passing method calls along. Flip the execution so the method is within the struct within the array, so it's not assigning objects within a method. Oh, like literally create a tree that is like a bunch of if-then statements for each tree. It's not a bad idea. That one's not a bad idea at all. That's not a bad idea. We can test that manually too by literally just code ginning. Oh, so what I read from you and what I interpreted was we literally like take the tree and then we just create a class that's like got one function called evaluate, and it's like if, and then it just takes, features 3, like literally putting constants in there via code gen, less than another constant, whatever, because we know the answer. And then what it does is literally just do this. If, and then it's just literally making a tree. Man, that might actually be really, really useful. Holy crap, that might be useful. Not only that, there's a really good way to do this using a library called Sigil. Wouldn't be hard to do this at all. That's a really good idea. Right, what we've done is we have gotten rid of the need to look up data from, this entirely gets rid of the data structure of the nodes and turns it all into like machine operations, like compiled. Yeah, essentially generating hard-coded logic. Although it's like, air quotes hard-coded. There's basically, instead of there being like a data structure of like tree nodes, you are literally code ginning a decision tree and all of the possible branches, and then compiling it to an assembly in memory. That sounds like fun. Okay, I'm going to put that on the to-do list. That actually sounds really good. And if that works, this still has benefit. I think we're going to get to 3.9. I really think it's going to get to 3.9. It's going to take a long time, but it's going to get there. And if it doesn't, I'm just going to increase the threshold and let it run longer. Probably go take a nap. Even at this point, I feel like this is a pretty big difference. Sigil. Yeah, that's right. That's exactly what it is. Sigil is like the technology that underlies the JSON library Jill. Jill is like one of the fastest JSON serializers for .NET. It was basically the thing that like showed how to do it fast, and then things like Newtonsoft and Service Stack started copying some of the core components. Not outright, like they still have their own interface, which is totally different than Jill, but it's entirely based off of Sigil. And basically, what Sigil does is it makes code generation really simple, and it prevents you from writing invalid code. At least that's the goal of it. Like code that would cause obvious problems. So instead of writing il.emit, you instead use Sigil, and Sigil creates all of the actual emitting parts, and you just sort of tell it what it is that you want it to do. So it looks more like real code. But I mean, trees are so simple, you could literally, there's no reason to not like literally code gen exactly this. And then just take it as a string and send it to the compiler. Okay, in any case, we do need to do this. Oh, wait, no. First. That one was a good idea. We're going to save that one. Where's the to-do? Try code gen the actual trees. You know what else is crazy? No, never mind. Yeah, just code gen the actual trees. Okay. There is another thing that you would get out of this, which is your returns become immediate. You'd no longer have to look them up, right? So, bring this back. Right now, to get to a leaf, you have to go if feature index, it really looks more like this. Feature index is less is greater than or equal to 0. Right? This is the step that we're really doing right now. And maybe this is actually part of why it's so slow. Right? You have to do both of these. Now you get this for free. You get to do this one when you're code genning. And then you just do this. Yeah, that was my original intention goal, to get rid of that lookups for assignments. Right. So you get to do this feature index check beforehand, and then in the case that like this is true and it is supposed to be a leaf, we no longer have to have this feature index check right here. Instead, it just becomes straight return, some value. And that is huge. It's sort of like taking all the leaves and shoving them up into the branch values of the previous level. I wonder if there's a way to do that. I bet that's enough right there to fix the problem. It doesn't matter what path you take, you end up landing on that extra lookup. You would literally get rid of one lookup from every single tree. And one branch. Wow, that one would be big, actually. That one would be really big. I wonder if there's a way to... Okay, now I really want to try that. All right, I have it on the to-do list. I'm going to implement this reorder thing so that once this like gets done spitting out whatever it's going to spit out, we can actually do the reordering. Fire it up. So in this XGBoost model, I want to get each of the trees. I want to create new trees, and I want to create a new XGBoost model. The other option is load the original file. No, I don't want to do that. That's stupid. And then like regex replace all of the feature names. No, that's stupid. I'm not going to do that. Okay. This is making a lot more progress than I sort of thought it would. That's encouraging. Okay. Let's get rid of launch, get rid of this. XGBoost. I need to recreate these. This is private. Maybe I make this public. Yeah, public. There we go. See what I did there? Then we go to the decision trees and we do the same thing for that. Public. Boom. Now what I do is I copy the decision tree nodes, only I replace them. Like here. Or like, no, you can't do a sealed struct. Sealed. And XGBoost. There's only one of these. I'm not sure if... Okay. I have no idea. How does that actually create like a performance boost? Or is it just that like the JIT is faster when compiling them? If you create an instance, it helps avoid vtable lookups. Oh, interesting. Well, let's see if that worked. Let's see if that did anything. I can just create a new terminal and run this again. cd space fast.modeling.test.net. No, I need to run this thing. Unless they've made changes in net core, but that used to be a thing in .NET. Okay. 229. It's difficult to tell. $224. I'm thinking it hasn't made a huge change. That one was a mistake. It doesn't really count. I'm gonna guess it. Yeah, very negligible at this point. I'm gonna leave it like that anyway. Okay, reorder. I have made the trees so that you can create new trees. What I need to do is say model.trees.select private static decision tree reorder tree. I'm gonna call this reorder XGBoost. XGBoost. Reorder tree. This one is going to take in a decision tree model and a short array reorder mapping. And this is going to say select reorder, nope, reorder tree, taking in a model, taking in an M, and a reorder mapping dot to array. And this is going to be var reordered trees. And I'm going to say var results equal new xg boost, taking in reordered trees. Return results. Okay. Then here I need to say model.nodes.select m new decision tree node. And then I want to say feature index equals reorder mapping of m.featureIndex. And then I want to say value equals m.value, true branch equals m.true branch, false branch equals m.false branch, dot to array, var reordered nodes equals var result equals new decision tree reordered nodes. Return result. Okay, I think that's going to be enough to do the reordering. Have to test that. Let's see how this thing is doing. Ooh, we're in the 3.9s. Still going. Man, maybe a better way to do this would be to do this in parallel. I mean, I've got like I've got 16 cores. Could do a lot more if we did 16 cores. Okay, another thing to worry about later. Like, we're just pumping away on one right here. Okay, whatever, we'll worry about it later. And then, well, I mean, maybe. Now I'm all kind of like, what if I just did? Yeah, I don't know. Okay. So this is all good. If this makes an improvement, I feel like at this point I really want it to kind of stop. I feel like it's far enough along that we would be able to notice a difference if there was going to be a difference. But unfortunately, I didn't program it to stop. All right. Anybody want to take bets on how far it gets? I am going to leave this running like until tomorrow. So it's going to stop once it tries 5,000 new swaps and doesn't find an improvement. Did I say 5,000? Did I make it 5 or 10? I made it 10. I made it 10,000. Once it tries to swap two different feature indexes 10,000 times without finding an improvement, it's going to quit. So if anybody wants to take a bet on how low this is going to go with like 2, I guess 1 point something being like the realistic minimum, like 1.8 being, if we found a perfect way of doing it, it would get to 1.8. I am entirely unconvinced that's going to happen. I'm going to say 3.85. That's where I think it's going. But if this is valuable, if this does work out and does improve it, then I think we'll actually put some real effort into solving this optimization problem in a more structured way. All right, the Hugo doll says 3.775. Let's do that. How low can you go? The Hugo doll, yeah. All right, 3.85. Anybody else? Okay. We have done the reordering. We can... You know, it's 3:30. I think I'm just going to take a break and go play a video game, honestly. And, like, chill out before my day ends. And let this thing just grind away. Alright, that's going to be it for the stream. Let's go ahead and raid somebody if anybody has any ideas. I'm also going to get this checked in. Save. Let's go ahead and find somebody. Discover. I'm seeing a lot of people on. Let's go with... let's go with Codephobia, I think, today. Alright, we're going to get this raid ready. I don't have anything to like spam and chat when you get there, but do drop a line and say hi and all of that. And thank you everybody for coming to visit. Thank you everybody who followed today. I really appreciate the raid. Rhyolite, thank you so much for that. And I will be back tomorrow at noon. Everything should be good to go. I don't have anything pressing tomorrow, so I expect to get right back on this, see if this was an improvement, and see how far we can push it. Alright, thanks everybody, and gonna go ahead and kick off this raid here in just a second. If you're interested in playing around with any of this, I am getting it checked in right now. It's on a branch. Thanks, Hugo. I really appreciate that, man. You have a good one, too. Alright, and here we go with the raid.